All right, our double angle formulas in Trig. This is a rather short section. It has one very specific type of problem that comes with it. If you saw the video on the sum and difference formulas, then it's a problem that's very similar to one of those. You will be given some information about, in this case, just one angle, and then you will need to find the sine of double that angle, like sine 2 theta, cosine 2 theta, tan 2 theta. So, what those problems look like would be something like this. They will tell you that sine of some angle, we'll call it angle x in this case. Sine of x is -4/5. And then they'll tell you which quadrant x is in. And sometimes they'll do that by saying something like this. So clearly, if angle x is between 270 and 360, then that means it's in quadrant 4. And anytime you're given information about an angle, almost 100% of the time, you want to sketch out that angle and sketch its accompanying triangle. You're probably going to use it at some point. So in this case, we know that this triangle is in this quadrant, and we know that this side is -4 and this side's 5 because sine is opposite over hypotenuse. And if we do Pythagorean theorem, this is a 3, 4, 5 triangle. So this side is 3, and we know it's +3 because of its direction. This is the positive x-axis, so this side must be positive. Now, pretty straightforward. They ask you for one or all of these formulas. You go straight to it. Well, let's talk for a second real quick though. Cosine 2 theta, don't let this confuse you. Yes, it has 3 different formulas that will always be written with it. You can use any 3 of these, whichever one is easiest. Just so you can see, it's actually pretty straightforward though how these other 2 are derived. If we take that first one and let's say knowing our Pythagorean identities for trig, cosine squared is equivalent to 1 minus sine squared, right? Because sine squared plus cosine squared equals 1. So then 1 minus sine squared minus sine squared, well, guess what? That's 1 minus 2 sine squared. Well, that's all we have written here. So all they're doing when they give you these is they're just taking that first one and saying, well, it could also be written 2 different ways if we use the Pythagorean substitutes. I would get this bottom one the same way. I would just take negative sine squared theta and substitute in for that cosine squared theta minus 1, right? Okay, so let's go back to this problem. If we want to find sine of 2 theta, call this part A. Actually, let's go ahead and do it in purple. A, we got sine 2 theta, which equals 2 sine theta cosine theta. I changed it to theta, it should be x, right? We made it x in this problem. Now, looking at our triangle, right? what's sine theta, or what's sine x, and what's cosine x? Well, sine x, we already know that, is -4/5. And cosine x is 3/5. So we got 2 times this times this. Remember, that's helpful to think of 2/1 sometimes. So our denominator is going to be 25, 5 times 5. Our numerator is 2 times -4, that's -8, times 3, that's -24/25. All right, so that's for sine 2 theta, or sine 2x in this case. Cosine 2x, again, we just come to our formulas, use either one of them. If I use if I use the first one, cosine squared, that's going to be 3/5 squared minus sine squared, well, that's -4/5 squared. That's 9/25 minus, and it's still minus because when I square a negative, that's going to be positive, right? Minus 16/25. Well, common denominator, 9 minus 16 is -7. So I have -7/25. All right. Tan 2x, we'll fit that right here. So tan 2x, we 2 tan x, right, over 1 minus tan squared x. So what's tan x? Well, we look at our triangle. Remember, tangent is opposite over adjacent. So that's -4/3. So we get 2 times -4/3 over 1 minus -4/3